Now we're going to be looking at special angles using trigonometric properties. So in this section as well, it's really useful if you have your exact value tables next to you, okay, on a piece of paper somewhere, and probably also the ASTC rule, the all stations to central rule. Okay, so let's get started. So there's a few cases here you're going to remember, but I'll show you how to remember them in some easy ways, okay? So starting with this one, cos 90 minus x is equal to sine x. And vice versa, sine 90 minus x will equal to cos x. Okay, so that's the rule that you have to memorize. And if you like, this one basically says if cos A equals to sine B, what is the relationship of A and B? Having a look at that. Well, as I told you, cos 90 minus x equals to sine x. Therefore, A and B, A plus B must be equal to 90 degrees. This is the rule. Okay, so this is another way of remembering that particular rule. Okay, so that one is saying the same thing. So if you have a case like that, make sure that A plus B must equal to the 90 degrees. All right? So that's that. So that's how the cos and sine have a relationship. So that's our first one. Now let's look at another one. And this is the relationship between cot and tan, or tan and cot. Okay, so it's very similar to cos and sine. Tan 90 minus x equals to cot x, or vice versa, cot 90 minus x equals to tan x. Okay, so it's actually exactly the same, but this time we're just using tan and cot. So similarly, as I showed you with the cos and sine rule, if tan A equals to cot B, in this case, A plus B must equal to 90 degrees as well, just like I showed you with the cos and sine. Okay, now if you're still confused with how this and that relates, I'll just show you. If I make A the subject here, I'll move B onto the other side, so I'll have 90 degrees minus B. Yeah, so A is basically 90 degrees minus B. I'll just put this into here. Okay, so tan A, which is 90 minus B, is equal to cot B. Okay, and does that look quite the same as that one there? Except here, instead of x, I used B, but it's basically the same, isn't it? Okay, so that's why this is the same as that. Okay, so this is another way you can remember it or approach the question that uses cot and tan. Okay, so that was a relationship between tan and cot. Alright, so take a look at that one and try to remember it. Now the next one is a little bit of a different type of relation. See how cos 360 degrees plus x equals to cos x. Okay, and the same one here, this time we're using sine. Sine 360 degrees plus x equals to sine x, just sine x. Okay, so this time cos is with cos and sine is with sine, so don't get confused. This is basically saying the one whole period of cos and sine is 360 degrees. Okay, so cos x, if I add 360 degrees to the input x, which will become cos 360 plus x, it's exactly the same as just cos x. So, because one period of cos is 360, no matter how many times you add 360 to x, it's actually the same answer. So if I give you a quick example, say I have cos, say 10 degrees. If I add 360 to 10, it will be cos 370 degrees. Put this one in the calculator and put this one in the calculator. You'll get the same answer. Okay, so even if you add 360 to the 10 degrees, it will give you the same answer. Okay, so although they look different, they're actually the same. Okay, so no matter how many times you add the period of 360, it's basically talking about the same answer. Okay, so that's what you can utilize. And the same with sine, it's exactly the same reason. You can add 360 to the input of x, and that will still indicate the same result. Okay, so remember that one. Now the final one I'm going to talk about is the tan. The period of tan is different to cos and sine. The one whole period of tan, we consider it as 180 degrees, so it's different. So tan, one period is 180 degrees, so tan 180 degrees plus x is equal to just tan x. Okay, so if I add 180 degrees to my x, okay, it's the same as just tan x. So as I showed you as an example, I'll do one more. Tan, say, 20 degrees. Okay, this time I'm going to add 180 to 20, which becomes tan 200, right? 180 plus 20 is 200. Put this one in the calculator and put this one in the calculator. They will be exactly the same. So tan 20 is equal to tan 200 because all I did was add one whole period, which makes no difference to the answer. Okay, so that was all there was for you to memorize in this section. So take a look, trying to remember those, and let's try some questions now. Starting with 31, it says simplify cos 90 degrees minus x. Remember our rule, guys? Cos 90 minus x equals to sine x. That's all there is. All I did was apply that rule. Okay? Now 32, tan 90 degrees minus x. What was that rule? Tan 90 degrees minus x equals to, what was the relationship with tan? It was using cot. So the answer is simply cot x. Okay? So remember the rule, guys. So similar to 31 as well. This applies to 31 as well as 32. That, see how tan 90 degrees minus x equals to cot x? And remember I told you that if tan a equals to, sorry, that was wrong. Cot, sorry. If tan a equals to cot b, what is the relationship between a and b? Well, a plus b must be equal to 90 degrees. Right, that's what I told you, right? So I hope you remember that. In this section as well, let's just check if that is true. So if tan 90 degrees minus x equals to cot x, the input of tan here, which is 90 degrees minus x, plus the input of cot here, must equal to 90 degrees. But let's see if that's true. See if negative x plus x, that cancels out, which is just 90 degrees. So that's how we apply that rule. Okay, so remember how I told you this stuff? Trying to relate to that as well, because that's also very useful. Okay, so that was the relationship between cot and tan, which I've already told you previously. Now in 33, we're going to find the exact value of sine 420 degrees. Okay, so 420 degrees. Alright, now 420 degrees is quite a large input, quite a large number. So what I'm going to do is say sine 420 degrees is the same as 60 degrees plus 360 degrees, isn't it? Yeah? So remember our whole period of sine was 360 degrees. So I'm trying to change it into this kind of form. Okay, where I'm adding 360 degrees to some value. So in this case, sine 140, I can just write that as sine 60. Okay, this value and this value is exactly the same result. All right, it's because all I did was subtract one period, which was 360 degrees. So look back at your exact value table. What is sine 60? Simply root 3 on 2. Hope some of you do remember this. Okay, that was question 33. Question 34, find the exact value of cos 765. Again, this input 765 is quite large, isn't it? So what I'm going to do is try to reduce it down to its number of maybe one period. Let's try doing that one. So 765 is the same as 45 degrees plus 720 degrees. Now guys, 720 degrees is what? Where did that come from? Well, this is just 360 degrees multiplied by 2. Okay, so I'm actually adding 2 periods to 45 degrees to make that the same as 765 degrees. Okay, so see where that comes from? So all I can say now is that cos 765 degrees, I can change that to just cos 45 degrees. Okay, that's where the cos 45 degrees come from. Okay, and this has the same result, so it's just a different way of writing it. So as you can see, all I did here to get to there is subtract 360 degrees twice. Okay, so now I get a decent looking number. So cos 45 degrees, again, go back to your exact value tables and tell me the answer. Simply 1 on root 2. Okay, and again, I hope some of you do remember this from that exact value table. So that was the answer for question 34. And remember, you can subtract your period of 360 degrees more than once. Okay, just keep subtracting it until you get a decent number. All right. Okay, question 35 says find the exact value of sine negative 495. This time, have a look guys, we have negative input, which I don't really like working with. Okay, negative input doesn't really help us when working out the answer. So what I'm going to do is try to make that into a positive input. Okay, and how do I do that? Well, remember in our previous few questions, we're trying to reduce it to the number of periods so we'll have a decent number. This time, because I don't like having negative inputs, I'm going to try to add the period of 360. Okay, so let's try adding one period. So I'm going to add 360 degrees to negative 495. So if I add this one, you should get sine negative 135 degrees. But this time, you still see the negative sign. I don't like having negative values. So what do? I'm going to add one more period. So let's try adding another 360 degrees, and this will make sine positive 225 degrees. So now I have a positive answer, which is good. So I've got the positive input. I don't have to worry about adding any more periods. Now sine 225. I'm going to use my all stations to central rule. This applies nearly everywhere, so make sure you always trying to utilize this one. Now 225 degrees, which quadrant is that one in? Well, it's going to be in the third quadrant, isn't it? Yeah, 225 degrees lies in the third quadrant. So we're going to be looking at this one. And remember, this one is 180 plus theta. Yeah. So 225 degrees is the same as 180 degrees plus 45 degrees, isn't it? Because 180 plus 45 makes 225. So what's our value of theta? Must be 45 degrees. So in this quadrant, is sine positive or negative? Well, it's the quadrant for only tan is positive, so sine must be negative. So negative sine theta, where theta is 45 degrees. Okay, so it becomes negative sine 45 degrees. What's sine 45, guys? Go to your exact value tables, or some of you can actually just tell me the answer. Should be 1 on root 2. So the final answer is negative 1 on root 2. Okay, and that's the answer to this question. So have a good look at that one. Okay, and that was pretty much the end of this section. And that concludes bearings and exact values. Okay, so see how our exact value table and our all stations to central rule applies in a lot of the questions, even in this section here as well. So make sure you're trying to memorize that until next time. Okay.